students, this is Conjugate and today we will start with paper 2, maths paper 2. In that we will start with the first chapter, that is a complex numbers. Now first we will recall some terms or some sets from your school, or you might have studied about some set of numbers, right? Like the natural numbers, integers, then rational number, irrational number and the real number. So one by one we will see all that sets. So first is set of natural number. Set of natural number means numbers that contain all the positive integers starting from 1, 2, 3, etc. up to infinity, right? So this is a set of natural numbers. Now the next is set of whole number. Whole number is same as the natural number, but it starts from 0. So it starts from 0, 1, 2, 3 up to infinity, right? Now the next is set of integer. So integer means a set of numbers containing all the positive and the negative together with 0. So it is 0, plus minus 1, plus minus 2, plus minus 3 and up to infinity. So till here we have the pure numbers, right? We don't have the fractions and etc. So the next set is a set of rational numbers. Set of rational numbers. Set of rational number means this type of set, A upon B form, like 2 by 3, 3 by 4, etc. The numbers in this form A by B, where A and B are integers, okay, are called a set of rational numbers. Now the next is a set of irrational number. Set of irrational number, a number in a root form, right? Root 5, root 7, like that. So that is nothing but the set of irrational numbers. Now the next is set of real number. Set of real number means it contains all the numbers, positive, negative, A upon B form, root, all the numbers. That means all these sets are subset of this bigger set, that is the set of real number. So in your school till now, till your 10th standard, you have studied these type of numbers. Now today we are going to see another set of numbers, that is a set of complex number. But before that, I want to explain you why we need this set, why we need this specific type of set of numbers, that is a complex number. Everyone knows about the equation and its solution, right? Now can you tell me what is the equation? Equation means it is an expression. I am giving you an expression, 2x plus 3. Is it an equation? No. This is an expression. This is not an equation. For equation, there should be equal to sign in your expression. Till here it is expression. Now I am giving equal to sign is equals to 0. Then this become an equation. Okay. So, can you tell me what is solution for the equation? Solution means a value that satisfies this equation, a value of x that satisfies this equation will be what? Will be solution for this equation. So how we will find out solution? See, this is the very simple equation. We can directly find its solution. Right? 2x is equals to minus 3. Therefore, x will be equals to minus 3 upon 2. Now, here we have got one solution for this equation, which is equals to minus 3 upon 2. Is it a natural number? No. Because this is of the form A upon B, right? So this is what? This is a rational number, or you can say this is the real number, because real number contains all these sets. You can say natural real numbers, right? So here we have got one solution in real number. So this equation has a solution in real number. Now I am giving you another equation, x square minus 1 is equals to 0. Now can you find out its solution? Yes, this is a quadratic equation. So it will be having two roots, right? So x square is equals to 1. That means x is equals to plus minus 1. Or you can say this is under root of 1, but under root of 1 is equals to 1 only. So this is plus minus 1. So the solutions are plus 1 and minus 1. See, whenever we remove root 2, we give the plus minus sign. One root for positive and one root for negative. Now, this solution also has a solution in real number, in integer. But if I give you x square plus 1 is equals to 0. X square plus 1 is equals to 0. Can you tell me what will be its solution? So solution will be x square is equals to minus 1. Right? That means x is equals to under root of minus 1. So do you have any formula to find out the root of negative numbers? No. Till now we haven't studied the square root of a negative numbers. Right? Since here we have such type of equations which does not have solution in your real number. Therefore, the mathematician discovered this set of number that is a complex number. In that, they have discovered minus I, or you can say I. So this is imaginary number. This is nothing but imaginary number, and its value is minus 1 is equals to I square. That is, I square is equals to minus 1. Therefore, I will be equals to under root of minus 1. So now we can find out its solution. See, so the solution will be x will be equals to under root of minus 1. That is under root of minus 1. What is the value of minus 1? It is I square. So this is I square. So this root and square will get cancelled and will get solution is I. So x will be equals to plus minus I, since we are removing root sign. Okay. So this equation has a solution plus minus I. But I does not belongs to R. I belongs to complex number. So this equation does not have solution in your real number. It has a solution in where? In complex number. So I hope everyone understand why we need a set of complex number. Since we have some certain types of equation which does not have solution in real number. So now we will see what is a complex number. What is a complex number? Right? So the complex number is a number of the form a plus id is a complex number. It is always denoted by z. Okay? So number of the form a plus id, one part, another part, and is always denoted by the z, is called a complex number. For example, z is equals to 2 plus 3i. So this is your complex number. This is the format of a complex number. Like you have format for the rational number a upon b, similarly we have format for the complex number. Note that here a and b should be a real number. A and b should be a real number. And this part, see here they have two terms, right? So this first term does not have the imaginary number. So this is called a real part. This is called a real part, and this part is called imaginary part. Imaginary part. Okay, and it is denoted by real part is denoted by R of Z or RE of Z, that means real part of Z, and imaginary part is denoted by IM of Z or simply I of Z. So this is the complex number A plus IB. So this is the real part and this is the imaginary part. Now I am giving you one example, 2 plus 3I. So here what is the real part? So R of Z is 2, right? And the imaginary part of Z is 3I. I hope this is clear. So always use Z to denote the complex number, right? So a set containing all the number of this form, a set containing all the number of this form where A and B belongs to where a real number is called a set of complex number. It's called a set of complex number. This is the set of complex number. And it is denoted by capital C. So this is your set of complex number. Next we will see what is imaginary number. What is imaginary number? A number of the form BI. A number of the form BI where B belongs to real number and I square is equals to -1 are called imaginary number. So we can take the examples of, so this is the imaginary number. BI means the number of the form, in this form BI will be an imaginary number. For example, 5I, you can take 2I, etc. So these all are imaginary numbers. We can also take an example, under root of -25. This is also an imaginary number. How? This is not in the form of BI, but -25 can be written as, this is under root of, minus means it is I square, right? And into 25. So this will be I and square root of 25 will be 5. Square root of I square will be I. And since we are removing square root, so this will be plus minus 5i. So these all are the imaginary number. Now we have some properties for imaginary number, which states that the first property is if you multiply an imaginary number with a 0, you will get 0. If you multiply an imaginary number with a 0, you will get a 0. Now second, if you have AI is equals to BI, two imaginary numbers are equal, then this implies your A should be equal to B. Right? A and B should be equal, then only AI will be equals to BI. And the third property is, if you have A is any real number, then under root of minus A square. Under root of minus A square will be plus minus AI. Why? Same case like minus 25. So you can solve this as, this is under root of minus I means I square into A square, which is equals to plus minus AI. So these are properties for the imaginary number. So we have a complex number. Now the another note is, I am giving you some examples. See, Z is equals to, suppose 3 plus The another example is z is equals to 3 plus 7i. Then z is equals to 3. Then next is z is equals to 5i. And the next is z is equals to 0. Here, this is the pure form of the complex number. 3 plus 9, 9. This is also the pure form of the complex number. 3 plus 7, 9. But here, z is equals to 3. 3 is a real number. 3 is an integer. But this is complex number as well. How? Because a z can be written as 3 plus 0i. Right? Here the imaginary part is 0. But we can express 3 in form of the complex number 3 plus 0 as this is also a complex number. And the such type of number is called a purely real number. It is a real number. You can say this is a pure, wait. So this is called as a real number. So z of the form a only where imaginary part is 0 is called a real number. Now the next number is z plus pi I. Here real part is 0, right? Here the real part is 0, only imaginary part is there. So such type of complex number is called purely imaginary number. Purely imaginary number. And z is equals to 0 is also a complex number. Why? Because 0 can be written as 0 plus 0i. Okay, so this is called a 0 or a 0 of a complex number. One more thing I wanted to tell you, as we have all the sets are subset of a real number, like natural number, rational number contained in real number. So the real number is contained in complex number. So we have one more bigger number, set of numbers, that is a complex number. Okay? That means this set of complex number, till now we have the biggest set of numbers among all these set of numbers. Now, the next topic is algebra of complex numbers. Algebra of complex numbers. First of all, you tell me what do you mean by algebra? Algebra means, now tell me, 2 plus 3 is equals to 5. 2 minus 3 is equals to minus 1, right? So in real number or in natural number, we define certain operations like that is addition, subtraction, multiplication, division, etc. So that are algebra of a real number, natural number. Yes? So similarly, we have the algebra of complex number as well. That means we can add two complex number, we can subtract two complex number, we can multiply two complex number. But here the method is different. So I hope algebra is clear to all. So we have the 4 algebra. So first we will see the equality of a complex number. We can see the equality. The first is equality of a complex number. As in natural number or in a real number, when we can say the two numbers are equal, can we say 2 is equals to 3? No, we cannot say. Can we say 2 is equals to 10? No, we cannot say. These two numbers should be equal, then only we can say 2 is equals to 2, right? So similarly, we have the two equal complex number. So if we can say a two complex numbers z is equals to C plus ID. Always note that you have to use the small letters to denote any complex number like A plus IP, C plus ID. Okay. So the two numbers Z and Z1 are said to be equal. That means A plus IP is equals to C plus ID if and only if A is equals to C, this real part should be equals to this real part, and the imaginary part should be equals to imaginary part. That means B should be equals to D. Then only we can say the two numbers are equal. Only if the real part is equals to real part and the imaginary part is equals to the imaginary part. Like this. Suppose you have Z1 as 3 plus I 9. Okay, 3 plus I 9. And the Z2 is equals to X plus I 1. Then Z1 is equals to Z2 if and only if 3 is equals to X and 9 is equals to 1. Now, as we have in a natural number, 3 is less than 4, right? Then 5 is less than 10. Or you can say 100 is greater than 1. Less than or greater than equality. But here we don't have that type of equality. We have only equal complex number. We don't have one complex number like this. 4 is less than I is greater than 5. Nothing like that. We have only the equality of a complex number. I hope equality of complex number is clear. Now, regarding this or based on this topic, question can come in exam like this. If X plus IY is equals to 4 plus 3I, this is example from page number 2. 4 plus 3I, then if X plus IY is equals to 4 plus 3I, then find value of XY. Find X and Y. So what will be our answer? The solution will be since X plus IY is equals to 4 plus 3I. Two complex numbers are even equal. So we can say that this implies X should be equals to 4 and Y should be equals to 3. Since we know that two complex numbers equal if and only if the real part is equals to real part and the imaginary part is equals to imaginary part. So this is your answer. Now the next term is a conjugate of a complex number. Next term is a conjugate of complex number. So conjugate of a complex number is, suppose you have Z is equals to one complex number A plus IB. Then a conjugate of this complex number will be A minus IB. And it is always denoted by Z bar. You have to just change the sign of this I. Plus I to minus I. So it will give you a conjugate. For example, I am giving you some complex number together its conjugate. So 2 plus 3I. Suppose this is Z and this is Z bar. Its conjugate is denoted by Z bar. Suppose 2 plus 3I, then its conjugate will be 2 minus 3I. If you have 2 minus 3I, the conjugate will be 2 plus 3I. You have to just change the sign. If you have 5I, a purely imaginary number, so its conjugate will be minus I, minus 5I. If you have 3, a purely real number, so its conjugate will be 3 only because it doesn't have I, right? If you have 0, 0 will be 0. If you have 2 plus under root of 3I, so the conjugate will be 2 minus of under root of 3I. I hope this is clear. Now we will see some properties of conjugate. Properties of conjugate. So the first property is z bar of bar is equals to z. Means if you take conjugate of the conjugate, you will get the real number. Means you get the number z only. For example, if you have z is equals to 2 plus 3i, right? So suppose its conjugate will be 2 minus 3i, yes? And if you take conjugate of this, so you will get 2 plus 3i, which is nothing but your original number z. So conjugate of conjugate will give you the original number. Now the second property is if conjugate of z is equals to z only, means it doesn't change, conjugate of z is z only, then your z is real number. Then z will be a real number like this. If you have z equals to 3, then the conjugate of z will be 3 only, right? Conjugate of 10 will be 10 only. So it will be a purely real number. Now the next property is property number 3, which is equals to if property number 3 is if z is equals to minus of z, if z is equals to minus z of conjugate, then z is purely imaginary. Then the z will be purely imaginary number. Z is equals to minus of z conjugate. Okay? That means if you have z is equals to phi I, if you have z is equals to phi I, then what will be its conjugate? Conjugate will be a minus phi I, right? So minus phi I, it will be equals to what? It will be a minus of z. That means a z conjugate is equals to minus of z. We can transfer this sign here, so the z will be equals to minus of z conjugate. Yes? So here that means if you have z is equals to minus of z conjugate, then your z should be a purely imaginary number. Right? So this property is just for a purely imaginary number. I hope these all are here for you. Now the next term, that means the next algebra, this was the first algebra of the complex number, that is a equality of a complex number. So the second algebra is addition of two complex numbers. Like we have addition of a numbers 2 plus 3 is equals to 5, 5 plus 10 is equals to 15. Similarly, we have addition of a complex number. Suppose you have first complex number a plus b and second complex number c plus I d. Then z1 plus z2. See, we know that 2 plus 3 will give you, if you take a natural number 2 plus 3, then it will give you again a natural number. Addition of two natural number will be a natural number again, right? Addition of, suppose 2 plus 3 plus 5 plus 3, it will be 7 upon 3. Addition of two rational number will be a rational number again. So similarly, the addition of two complex numbers should be again a complex number. So we have to add complex number so that it forms a complex number again. So for that, what we will do, we will add real part with real part and the imaginary part with imaginary part. So the addition will be A plus C plus I common B plus B. We have taken I common from these two terms. So again this is, suppose this will be some C1 plus I into D1. This is of the complex number form. Yes? Since A and C are the real numbers, so the addition will be a real number again. And B plus D will be again a real number. So we have named that as C1 and D1. And we have taken I common. So Z1 plus Z2 is of the form C1 plus I into D1. So this is also a complex number. So this is a addition of two complex